Problem solving where we're going to apply math to situations where math can help us come to a solution. This is probably the most important thing you can learn how to do. Math is a big part of this. I studied physics in college. Physics is, it's math. The math involved, when I did a physics major, I ended up being actually only one class short of being a math major. I mean, that's how much math you do in physics. It's just all math. But the focus is very different. Whereas in theoretical math, you're studying abstractions. You're studying things like set theory and just properties of numbers, things that are completely abstract. In physics, you're trying to use math to understand and build models that explain the way the world works, right? Like, for example, if you wanted to shoot a cannonball up in the air at some angle and know where it's going to land, that's easy to do in physics. If you know what the angle of the cannon is and you know what the muzzle velocity is, how fast is the ball leaving the tube, then you can accurately predict where that thing's going to land, right? Using math. There's a simple, very, very simple math model for that. It's just a quadratic equation, no big deal. Ignoring air resistance, at least. It gets a little more complicated if you involve air resistance. But that's kind of the focus of physics and other things too. But I think physics and engineering probably more than other sciences, where it's just really about solving problems using mathematical models. I would claim that this is probably the most valuable skill you can develop as a student. Valuable in what ways? Well, it makes you versatile. I mean, if you're thinking in terms of just your understanding of the world, I think that's huge. Like, this is going to sound pretty geeky, but when you study physics, one really cool thing is that you're always asking and kind of explaining to yourself, why does that happen? And it's really gratifying to just understand why that happens. I'll give you one. This just happened the other day. I'll give you one really stupid example. Have you ever noticed that in Pendleton, especially where it's windy, have you ever noticed that, like, when you open up the toilet lid, if it's really windy, the water level goes up and down in the toilet sometimes? Have you ever seen that? Like, if there's a gust of wind? Okay, watch for it. It happens. It happens, definitely. That's just some simple physics. And if you know a little physics, you can power through that and think why that's happening. It's kind of cool just to be able to see these little things going on. If you're going fishing, you're going to notice that if you're going fishing at a clear lake and you're wearing polarized sunglasses, there's going to be some angle where you're going to be able to look in the water and see the fish very clearly, and other angles where you're not. Right? Again, it's just all a bunch of physics, just a bunch of math, but it applies to these real situations. And so there's all these little instances during the day when understanding how the math applies is really pretty cool. If you want to think in terms of maybe something a little more concrete, like a career, right? And people typically, one of the factors you're going to consider when you choose a career is probably your income, right? I mean, yeah, obviously I'm a teacher, so it wasn't such a big deal for me, probably, right? But I was an electrical engineer before I was a teacher. Um, this pays off. This really pays off. If you look at, like, for example, my son's an engineer in college, just started a sophomore year. He's looking at kind of what he wants to do, and he and his buddies. He's going to be an electrical and computer engineer, so he's going into engineering. But some of his friends are math majors. The average salary for a math major coming out of his college is like 280 grand as a first year out of college. That's it. If they become what's called a quant, which is a quantitative economist, and he's kind of deciding this too, if this is something he eventually wants to do. You go work in finance, like typically on Wall Street. And these guys start off, their starting salary right out of college, if they do this, is almost guaranteed to be at least 600 grand a year. How come? Because they can do that. You can solve problems. That's all they care about. They don't know if you know anything about economics, because if you can do the math and you can be a problem solver like this, just go read an economics deal. That's easy, right? Those are not high level concepts. Those are just simple things. If you can do the math, though, that takes years and years and years and years to develop. But once you develop that skill, if you choose to, you will be richly rewarded for having the ability to solve problems, right? So just kind of keep that in your back pocket. I'll share some other data. Someday we'll talk about career options, just when we have a break in what we're doing, and we'll give you a little more information. But this, when you first see this, people probably, I can understand. I was in high school too. You look at this and think, oh man, story problems. Gosh, I'm going to hate this. This is the stuff that's important, though. This is arguably more important than all the other stuff we do. Okay. So how do we approach solving problems? This is, this the gospel on that? No, not at all. This is just our textbooks interpretation of the process of solving problems. There are other textbooks that would look slightly different, but they would all have some things in common, right? There, when we're doing problem solving, some of the steps that we do internally and mentally are real consistent. So what do we do if you're trying to solve some, and we're going to look at some here in a second. First thing is understand the problem. You got to know what you're doing. It might be an applied problem. It might be an abstract math problem. Again, I'll just go back to Andy was telling me he did it like last year in one of his math classes, in one of his pretty high level math class, and it's pretty complicated. He had to stare at a problem literally without writing anything, saying it, just staring at a problem and thinking for 4 hours before he even knew what to do on the problem, before he even like knew how to approach it. That's, I remember experiences like that too. That's not abnormal when you get into hard problem solving. You got to let your brain wrap itself around what's going on. You have to understand the problem. What's even being asked? What's the background I could apply here? What do I know that might be useful? What have I done in the past that might establish a pattern that would be useful? That's a big part of it, is just allowing your brain to be absorbed in the problem, right? And you can't shortchange that. You have to be very patient when you're solving high level problems, because your brain, it's amazing what your brain will figure out if you give it time. I can remember many times in college looking at a big quantum mechanics problem thinking, there is zero chance I'm ever going to be able to do this problem. I have no idea what to do. But eventually, if you just kind of stew on it and think about it and you kind of get an idea, and before you know it, it works. It's just amazing how it always works. Math comes to the right conclusion and solution if you just follow the steps carefully and just let yourself go. But you have to train your thought on the problem sometimes and really think about it. So that might involve what? Read and reread the problem, maybe many, many times. Propose something and just check it out and see how it pans out. Don't be afraid of failure, right? I know you've probably heard this before, but you learn more from failure than you do from success. If you succeed with something, you really haven't probably learned a whole lot. Maybe you've cemented a process in your brain a little bit and reinforced a connection and made it stronger, which it has some value, but you really haven't learned anything new. It's when you fail that you have an opportunity to really learn something significant, because there's a reason you failed. You were lacking some conceptual understanding that you have an opportunity to build, right? So failure is good. It's what pushes you to learn new things. Try stuff. If it doesn't work, big deal. Start over. A lot of times, and this is really a big deal. See if you can graphically represent this. If you can draw some kind of a diagram, doesn't have to be geometry, but if you can find a way to represent things, sometimes the act of just putting pen to paper and writing stuff down really just unsticks your brain. Okay. So then what? Once you got an idea, this is where we kind of start getting into math mode a little bit. This is where a lot of times you have to declare your variables, define your variables and write it down, because if you have lots of variables, eventually, not so much this year, but in your future, hopefully you're all going to go on and do more math. You're going to get into multivariable calculus and things like that, where you've got multiple variables and you got to know which variable is what, and you got to write that down or you can forget. So write this stuff on paper. See if you can make the transition translating from some kind of an applied problem into something that's mathematical, that's clear. It's unambiguous. We write it in terms of math symbols and math notation, and then it gets easier to deal with. Then you can flip all the way into math mode, forget about the application for a while, and just do math. And then finally, when you're all done, sometimes you got to go back and say, okay, here's my math result. Now, how does that relate to the actual problem? Because sometimes it's not obvious. Okay. I've spent a lot of time talking about this, but that's because I think it's so important. I really do. Okay, let's look at some, and these aren't like they're super super advanced problems, but they're problems. I mean, people look at this, and I would say the majority of high school students look at this and immediately they kind of start to panic a little bit and their ability to problem solve just plummets. You can't panic when you see words. You just have to give it a little time, right? So, what do we do here? Read it. Everybody read this a couple times. Let's see if we can't tackle this one together. So, what am I trying to do here? Sometimes restating it is helpful. What's going on? Okay, we want to find the original price that was listed on the website or whatever before we applied the tax, right? Okay. We know that the total amount that we paid was that much, $449.40, after tax was applied. Okay. So throw out some ideas. What can we do here? We got to understand, I think we understand the problem. Maybe we need some variables now. What could we say? What do you think? An idea? It doesn't have to be right. Just throw something out. What do you think? Okay, but and what by the price of the television, you're talking about the original price of the television, right? Exactly. Now, a lot of times, the variable you're looking for is really it's the unknown, right? You guys have kind of used those words interchangeably in the past, unknown and variable. Well, the unknown is what we're trying to find. If this problem we're asking, uh, how much did we pay for the TV? We don't need any algebra or anything fancy because that's just a number that we can see there. That's a trivial problem. What's interesting about this problem is they're asking for something that's not known, that's not given to us. So almost always you can say, well, my unknown, let's just call it X, equals the, how do we want to say this? Say it again? Original price. There you go. Good. Original price. Okay, good. So now using that X, even that probably helps a little bit, right? What could I do now to make an equation that's going to involve X and is going to somehow include the numbers that are given to us, 7% and my final purchase price? Say it again. Okay, so one thing we could do, this is the final amount, right? So let's amend that slightly. What would I subtract from my final purchase price to find the original price? Okay, okay, good. So we could start with, we know that 449.40 minus, and that's the original. If we want to think of this in terms of words, that's my final price, right? We'll call it purchase price minus the amount that we're taxed. We'll just call it tax, right? Minus tax is going to equal the original price, right? Okay, so then I know over here I'm going to get equals X because that's my original price. How do we calculate tax? Okay, good. The percent times the value, right? Times the original price. The original price times the sales tax tells us what our tax rate is on that, or not tax rate, the tax amount. Okay, so that's going to look like, what is 7% as a decimal? 0.07. Okay, so 0.07 times the original price. Well, that's X. Okay, now we have an equation that we can deal with, right? Okay, no big deal. How would I solve that equation, that purple equation? And this is kind of messy, but this is good, right? That is something we can flip into math mode and sink our teeth into and just crank through, right? Once we've converted it into an equation, I call it flipping into math mode, right? We can ignore everything else and just laser focus on the math. So what would we do there? Where are we going to push the x's? Right or left? Good, to the right. So we'll add 0.07x to both sides, and I end up with 449.40 equals, what's x plus 0.07x? Yeah, that's like 1x plus 0.07x is 1.07x, right? Okay, and then we just divide by 1.07 and we got it, right? No big deal. Okay, I would say that another way of thinking about this would take you directly there. Okay, let's just think about this. Like, this was fine, totally fine. Could we have jumped right to this though? Yeah, we really could, right? Because if the tax rate is 7%, if you're paying a 7% tax, what percentage of the original price are you going to end up paying? 107%. You pay the original 100% of the purchase price plus that additional 7% tax. And so you probably could have just jumped right to this and said, well, 107% of the original price is my final price. Okay? And if I divide both sides, I promise you, if I divide both sides by 1.07, I'm going to get this number. Whoops. Okay? 420. Okay? All right. Have a good one. See you tomorrow. I'll put this assignment up so you can start on it. Actually, I think it's already up. Accidentally. I didn't mean to put it up, but I think I did. Yeah. You too. See you later.